Okay, I'm going to go through a couple of inclined plane problems here. These are actually from your homework, so I'll get situated. All right, so let's draw our free body diagram of our object on our incline. So here is our incline. That's pretty steep. That's okay though. And this is the angle between the horizontal surface and the inclined plane. So we've got an object on this plane. Remember, it has a force of gravity vector that's straight down towards the Earth, and then a normal force vector that is perpendicular to the plane. And because those two are not lined up, this one's at an angle to the plane. Remember a couple of things. One is that this is our x-axis. This is our y-axis. So we're tilting ourselves. We're going to have a component of the force of gravity along this y-axis. I call that FGY. And then we've got another component here. I'm going to draw it here just so it's a little easier to see, called FGX. And so we're really using this triangle here. We're using this angle, and these two angles are the same. They're congruent to each other. I think congruent's the right term. And then our friction is going to be back the other direction up the ramp. So if we're moving down, which we are going to be moving down due to gravity, then friction is going to be in the opposite direction because it works against our motion. Okay. Okay, so we've got a 200 kilogram box, a 25-degree angle. We have a mu value of 0.15. That's our coefficient of friction. And we want to find our acceleration. So we got to go through all the way through all our calculations here. So we can start with our components of force of gravity. We're going to have FGX equals an FGY. Okay, so we're just going to go ahead and start with those. We could also just calculate FG because we're going to need that. That's 200 times 9.8. So remember, that's just mass times G. I got 1,960 newtons for that. And then my X and Y components are going to be this number, my force of gravity vector, like my combined vector here, times sine or cosine of the angle, depending on which one. So for FGX, I'm going to have FG sine of the angle. So that's going to be this number times the sine of 25. And then FGY is going to be FG times cosine. And that's, again, I'm using this triangle. Okay, I'm using this angle here. FG is my hypotenuse. So if I'm using this angle, Y is my adjacent side. That's why I use cosine. And then sine is my opposite side. That's why I'm using that for the X piece, because it's the opposite side. So I got, let's see, 1,960 times sine of 25 gives me 828 for FGX. And then 1960 times sine of 25. Oh, whoops, I already did that. 1960 times cosine of 25 is 1,776 newtons. So those are my two components. And I know, because of the way this is set up, that my normal is offset by my force of gravity Y. So normal equals the same number here, 1,776 newtons. And that's because the way we've defined this by tilting ourselves, we are not moving up and down in Y. we're balanced in y. So Fn equals Fgy. Then force of friction is going to be my normal force times my coefficient of friction, which is given up here. So I'm just going to multiply 0.15 times 1776. And that gives me 266. And now my F net is going to be my force of gravity X minus my force of friction. Because I'm moving down the ramp, okay? And so all my movement is in my X axis, which is my incline. And so my unbalanced force is going to be the difference between these two, okay? So Fgx minus Ff equals 828 minus 266 equals 562 newtons. And then my final step, if I want acceleration, I'm just going to take that F net and divide by mass. So I got 562 newtons divided by 200 kilograms. That was given 2.8 meters per second per second. Okay. So we'll do another one. I'm not going to redraw the free body diagram just for time purposes, but it's going to be the same thing here. But we'll reference back to it as needed. This is a similar problem, just different numbers. 150 kilogram for mass, 45-degree angle, 0.44 mu value, and we want to find acceleration again. So same steps. Fg equals 150 times 9.8. I got 1470 for that. Fgx equals Fg times our sine of our angle here is 45. So that's going to give me 1039 newtons. And if you might already know this because you know sine and cosine, but Fgy is Fg cosine 45, and that is also going to be 1039 newtons because sine and cosine are going to have the same value for 45, which is 0.707. Okay, so 45-degree angle. Normal, same as Fgy, 1039 newtons. So again here, remember that normal and that Fgy are offsetting each other because we're saying this is our y-axis. Force of friction is my mu value times normal force, which is 457 newtons. And then my F net is going to be my Fgx minus my Ff. Again, same problem here where we're moving down the ramp. So our net force, our unbalanced force is going to be the net between these two guys. Okay. All right. And then, let's see, that's 1039 minus 457. I got 582. Let me make sure that's right. $582. Yep. Okay. I just thought that was weird because that's similar to this number, but that's okay. All right. And then acceleration, F net divided by mass is 582 divided by 150. And that is, I got like 3.88 or 3.9. You could round it. That's fine. Meters per second per second. So, All right, so I'll continue the homework in the next video.